We're tackling sort an array. Our goal is to sort an array of integers in ascending order using an optimal solution that has time complexity of O n log n time and O1 space. We're given an array of integers called nums and need to rearrange its elements in ascending order, returning the sorted array. It's important to note that we should solve this problem without using built-in functions, while aiming for that O(n) log n time complexity. Additionally, we're striving to minimize our space complexity too. There are 4 methods that are shown here, and you have to choose the most optimal among them. They are A. Selection sort, B. Shell sort, C. Count sort, or D. Insertion sort. I'm going to pause for a couple of seconds while you make your choice. So, for those of you who are able to get this, congratulations. And for those of you who just want to see some code, the answer here is C, counting sort. The brute force approach could be any one of the other 3 methods here, shell sort, insertion sort, or selection sort. And in our hint button, we talk about the bubble sort being a potential brute force. I wouldn't recommend even bothering with it. In any case, let's look at our optimized solution. Before we talk about the counting sort, I'd just like to point out the constraints of the problem. With the constraints being from values of negative 50,000 to 50,000, we know that if we're applying a counting sort, we're going to need to make sure that all of our values are non-negative if we're modifying our array. So, that's quite a major hint dropped as to how this is going to work. And in the first line you can see we've got this shift value. So, for the counting sort algorithm, we modify the array by adding a constant shift value to all elements. Once we've done that, we then find the maximum value within our modified array. After that, we use the max value to create a count array so that we can store the frequencies of each element within it. Finally, we can reconstruct our sorted array just by using the count array, and that's shown down here. So that's a very basic walkthrough of what's going on. Let's go through it line by line. So first of all, we've got this constant shift with the value of 50,000. This is added to all elements in the array to ensure that they're non-negative. One thing I've added here is we're using n as the size of our input array nums. After we've modified our array, we're then looking for the maximum value in it. To start with, I've initialized the variable max value with the first element of our modified array nums. After that, we iterate through the modified array starting from our second element at I equals 1. Inside the loop, we compare each element with our max value, updating it if a larger element is found. After that, we use max value to create a vector called count with a size of max value plus 1. This vector is used to store the frequencies of each element. After that, we iterate through the modified array nums once more. For each element, we're incrementing the corresponding index in the count vector. Once that's done, we're initializing this variable index with 0. IDX, or index, will be used as the index when we reconstruct our sorted array and return it. With the index established, we then iterate through the count vector from 0 all the way up to that max value that we calculated. Inside the loop, we iterate count I times, updating the nums array with the sorted elements by subtracting this shift value here. In addition, each time we add a number to our array, we're making sure to increment the index. Once that's done, we should have our sorted array nums as our result, and that's what we return. So, just by following this count sort approach, we can efficiently sort the array in ascending order in O(n log n) time. So, thanks very much for making it through this video. I would recommend that you check out this Udemy course, which is Algorithms Part 1. Dr. Ibrahim offers a real masterclass in using sorting algorithms for the first part of that course. To round off this video, we'll just look at the problem and answers one more time. And as you can see, you'll be using the counting sort to correctly solve this. Our application, Coding Card Sharp, offers an explanation for each answer you choose, whether it's correct or wrong. And we should also have code available in C++, Python, and Java as well. So that's everything for now. The next problem in the learning mode for the algorithms course of our app is minimum absolute difference. There you are. We'll be covering that soon.